Think about how you use AI today. You open it, you ask, it answers, you close the tab, and then nothing happens while you live your life. The report still needs writing. The booking still needs making. The email you keep putting off is still sitting there. The AI did its bit and went dark because it is reactive. It waits for a prompt. Now imagine one that does not wait. It runs on its own clock, watches your apps, and acts on your behalf while your phone is in your pocket. That is the idea behind Gemini Spark, which Google announced at its developer conference in May of 2026. Google's own definition is that Spark is your 24/7 personal AI agent that helps you navigate your digital life, takes action on your behalf, and is under your direction. But Spark is just the example. The real subject is a shift from AI you prompt to AI that runs on its own and acts for you. So let us see how it works, where the catch is, and why the hard part is not the doing. It is the trusting. Start with the cleanest frame. Spark is an agent, not a chatbot. Google draws the contrast itself. A chatbot is an assistant that answers your questions. Spark, in their words, is an active partner that does real work on your behalf. An agent does not just talk. It takes proactive action under your direction. The product is built from 3 pieces, and these are Google's own labels. There are tasks, multi-step jobs across your connected apps. There are skills, reusable instructions you teach it once in plain language which stick around across sessions, so the more you use it, the better it learns your preferences. And there are schedules which let it run on time-based or conditional triggers. That third one is the piece that makes it proactive, and we will come back to it. One balance to hold from the start. Google says it operates autonomously, but always under your direction, and is designed to check with you before major actions. Every app connection is turned off by default, so this is not an AI that does whatever it wants. It is bounded autonomy, with the doors shut until you open them. Here is the best aha of the whole topic, and it sounds like magic until you see the trick. Spark works in the background 24/7, even if your phone and laptop are turned off. Your devices are off, and it is still working. People hear that and assume something clever is running on the phone. The opposite is true. Spark does not live on your device at all. It runs as a persistent process on dedicated virtual machines on Google's cloud. So the reason your device being off does not matter is simple. The agent was never on your device in the first place. It is hosted elsewhere, always awake, and your phone is just one screen you glance at it through. Picture a phone switching off on a desk while an orb keeps pulsing in a cloud above it. The work is up there, not down here. Once that clicks, always on stops being magic and starts being architecture. As for the brains, the consumer page says it runs on Gemini 3.5 Flash, the model, paired with a harness called anti-gravity that drives it. Treat the exact version labels as a moving target, but hold the split. The model is the brain. The harness is the scaffolding that puts it to work. So why is this a turning point and not just a feature bump? Because of one conceptual leap. A reactive chatbot does nothing while you sleep. A proactive agent has its own clock and its own triggers, so it acts without you starting it each time. That is the biggest jump for you to internalize, and it is the durable lesson, independent of Spark, of Google, of this year. The frame to keep is, AI you prompt becomes AI that runs on its own and acts for you. Sitting right next to it is the idea that actually matters. Autonomy is not a switch, it is a spectrum. How much an agent may decide on its own is a dial you turn. And here is the uncomfortable part. As you turn that dial toward more autonomy, convenience goes up and risk goes up with it. They move together. Handing real actions to an always-on system, send this, book this, spend this, is fundamentally different from a one-off chat. And to be clear about the moment, this was not Google alone. Around the same time, the major labs all shipped consumer agents that act on their own. So the category is the story, not any single product. Call Spark among the first cloud-based ones and move on. So what can it actually do? Out of the box, it connects to Google's own apps. Mail, calendar, drive, docs, sheets, slides, the video app, the maps app. All of them off until you switch them on. A typical move is to pull the facts from your emails, your docs, and your sheets and write you a draft. But it reaches beyond Google too, using an open standard called the Model Context Protocol, a uniform way for an agent to plug into outside apps. Launch coverage mentioned things like a design app, a restaurant booking app, and a grocery delivery app, with more being added. Think of those as examples of connected apps, not a fixed list, because the list keeps changing. The work it handles is not one chat turn. It runs long horizon tasks, jobs that take minutes or hours, decomposing a goal into steps and grinding through them in the background. And the trigger layer ties it together. A schedule can fire on a time, like the first of every month, or on a condition, like when a matching email arrives. So it can quietly watch a statement and flag a hidden subscription fee, or assemble a monthly invoice and send it on its own clock. There is also an enterprise version, the same agent with broader business connectors and a more locked-down runtime, but the pattern is identical. Now the heart of it. How does an agent actually do anything? Underneath it is a loop. The harness drives the model around 4 steps over and over. Plan, act, observe, repeat. It reads the goal and the current state. It decides the next step. It invokes a tool to take that step. It observes the real result, what actually came back. Then it plans again and goes round until the job is done or it needs you. That loop, not the size of the model, is what the word agentic really means. A model on its own just produces text. A model wrapped in this loop, with tools and the ability to read back what happened, can chase a goal across many steps and correct itself when something fails. The harness is built to run several of these loops at once, as parallel subagents, and to keep them going on long jobs. Picture an orb walking a 4-node cycle, reaching out, getting a result flashed back, rethinking, reaching again, with a couple of faint copies working alongside. The tools change from task to task. The loop never does. Let us slow down on the act step because it is the part people picture wrong. The model does not magically reach into your inbox. It acts on the world only through tools, and a tool here is a connector to an app. There is a clean mental model. The model is the brain. The tools are its hands. The app connectors are the sockets the hands plug into. The way it plugs in matters, and it is a real mechanism point. For Google's own apps, Spark works through the app's actual programming interfaces, what engineers call APIs. It is not reading your screen and clicking pixels like a person with a mouse. It is making clean, defined calls, which is why this is more predictable than agents that drive a screen visually. For outside apps, those same hands plug into the universal socket that is MCP. So 2 kinds of tools, one Google and structured, one third-party and standardized, but the same picture. The orb extends an arm, snaps into a socket, does one defined thing, and reads the result straight back. That reading back is the whole trick that lets it correct itself, instead of guessing once and hoping. If a tireless agent is holding the keys to your apps, the obvious question is, how is it kept from going off the rails or leaking your data? With a layer of standard safety machinery. And here I want to be precise about scope, because Google spelled this out for its enterprise version. In that setting, each task runs in a fresh, strictly isolated, throwaway virtual machine, so one job's data never bleeds into another, and the machine is destroyed when the task is done. All traffic routes through a secure gateway that enforces data loss prevention checks, watching what is allowed to leave. And your actual credentials stay encrypted and are never handed directly to the agent. It gets a temporary token, not your password. These are the timeless primitives of agent safety. Isolation, so a failure is contained. A gateway, so nothing slips out unwatched. Credential-brokering, so the keys stay in the vault. Picture each task spawning a sealed bubble that pops when it is done, a gateway ring stamping or blocking whatever tries to pass, and a key that never leaves its vault. Just keep in mind that detailed isolation story is the enterprise description. Treat it as how this class of system should be built, not a promise about every consumer setup. Now we arrive at the heart of this whole story, and it is not a technical detail. It is a trust problem. A 24/7 cloud agent with access to your inbox and your calendar is a different bargain than a chatbot you open, ask one thing, and close. With the chatbot, you grant one-off permission. You approve a single action once and it is over. With an always-on agent, you grant standing access. You hand it a permanent key to your inbox, your calendar, maybe your wallet, and that key stays in its hand continuously, whether or not you are watching. That is the catch. Not that the agent is evil, but that holding a permanent key to your digital life is a far bigger thing to give away than approving one action at a time. Picture the difference. A one-off is an arm that taps a port and retracts. Standing access is a permanent lit cable with a key that travels in and just stays there. Every convenience of an always-on agent flows from that standing access, and so does every risk. The doing is the easy part. Deciding how much standing access to grant is the hard part, and it is the real subject of this video. So how do you make standing access tolerable? With the same primitives that survive any product. First, least privilege. Permissions are off by default, so the agent starts with access to nothing. Second, scoping or whitelisting. You decide which apps it touches and later which merchants and what budget. The advice that generalizes everywhere is, start conservative. Connect the one or two services where you actually want it to act and expand from there. There is no reason to hand it everything on day one. Third, and most important, the human-in-the-loop approval gate. Spark is designed to ask you first before high-stakes actions like spending money or sending an email, and the enterprise version requires explicit approval for high-risk steps like sending mail. Notice the careful phrasing. Designed to ask. That is the ship default behavior, not a mathematical guarantee, so hold it as the intended design, not an unbreakable law. Routine, low-risk steps run on their own. The gate sits only in front of the irreversible ones. Picture most cables dimmed because they are off, one or two lit because you allowed them, and a checkpoint on the lit ones where the reaching arm stops and waits for a human tap before anything big goes through. Now the part almost everyone gets wrong, payments. You will hear that Spark buys things for you on its own. Today, that is not the ship behavior. The opposite is. It is designed to ask you first before spending money. Every purchase needs your confirmation. So do not picture an agent quietly draining your account. Picture a wallet behind a gate that is closed, where a hand taps confirm each time. What is announced for the coming months is delegated spending with hard limits, where you authorize payments up front by specifying a budget and which merchants are allowed. That is not a blank check. It is a constrained allowance, and it is where this is heading, not where it is. And here is the deep part shallow coverage skips. The plumbing for safe agent spending already exists, as an open standard Google calls the Agent Payments Protocol, introduced in September of 2025 with dozens of partners including major card networks. The mechanism is cryptographic contracts called mandates. An intent mandate captures your request and your rules up front, your price limits, timing, and conditions for when you are not present to click. A cart mandate locks the exact items and exact price the moment you approve, so what you see is what you pay. Together they make a tamper-proof, signed record of what you authorized. One honest caveat. That protocol is Google's standard generally, and tying Spark specifically to it is implied by coverage more than stated, so hold that link loosely. So how does Spark sit next to the others that arrived the same year? The cleanest way to compare agents is to ask one question. Where does it live? Spark lives in the cloud. It runs on Google's machines, works while your device is off, and acts through structured app interfaces. The agents from the other major labs took a different path. Some live in your browser or on your desktop, driving websites and apps the way a person does, by clicking and typing on the screen in front of you. That difference is the whole story. A cloud agent gives you true 24/7 unattended work, but can only touch what it has a clean connection to. A desktop or browser agent can reach anything on your screen, which is broader, but it needs your machine powered on and is generally less predictable because driving pixels is fragile. Picture a cloud orb floating above a switched-off laptop versus a hand clicking a screen on a powered-on one. Neither is the winner. Each wins a different job. The rough consensus is to use a cloud agent for genuine unattended work if you live in Google's apps, and reach for the desktop and browser ones for broad, on-screen, hands-on work. Pick the right tool for the task, not a champion. So how would you actually run this, and what does it cost? The usage loop is short. You go into settings and switch on the 1 or 2 app connections you actually want, since everything is off by default. You optionally teach it a skill, a line or 2 of plain language instructions it reuses. You set a schedule, a time, or a condition that wakes it, and then it works in the background and pings you for approval on anything high stakes. Connect, teach, schedule, supervise. On availability, be specific, because this is a moving target. As of mid-2026, Spark is a beta. It is limited to the United States, to adults 18 and over, to subscribers of Google's top AI plan, plus some business users. It is not generally available, and it is not global, so it is not something a viewer anywhere can simply go and use today. The takeaway you keep is the concept, not the access. On price, there is no separate charge for Spark. It is bundled into a tier called Google AI Ultra, which sits at around $100 a month. To be precise about what happened, this Ultra tier is where Spark lives, while a separate, older top tier, which had been $250, was trimmed at the same time. So the two numbers are not one plan being halved. That $100 figure for Ultra is well corroborated, but the exact tier structure shifts, so check the current pricing the day you try it. Now the part you should not skip, because an explainer that only sells is not honest. The defining risk of an always-on agent is prompt injection. An agent that reads arbitrary web pages, emails, and calendar entries can be hijacked by malicious instructions hidden inside that very content. The attack rides in on the thing the agent is supposed to read. This is not hypothetical. Early in 2026, researchers demonstrated it against Google's own assistant using poisoned calendar invites. A hostile instruction was hidden in an event's description, and when the assistant read it, it could be made to quietly leak the user's private data. Google fixed that specific instance after it was reported, but the class of attack is live, and present tense is correct here, because it is genuinely true right now. And it may be deeper than unfixed. It may be unsolvable. One red team of an agent payment setup hit a 100% success rate at manipulating which products got recommended through hidden injected instructions. And a separate research argument reasons that no defense can both allow every legitimate request and block every attack. Tighten the filter and you reject honest requests. Loosen it and attacks slip through. A seesaw that cannot sit flat. Frame that as an honest, industry-wide open problem with a may in front of it, not as fear. 2 more real limits. Spark is, by Google's own words, very early in its product journey, with the interface telling you to supervise closely and check its responses, so expect mistakes. And because it holds standing access and runs unattended, a single wrong action, a bad email, a leaked file lands while you are not watching. The blast radius of a mistake scales with the access you granted, which is exactly why least privilege is not optional. It is the point. Before we close, a quick myth check, then the lesson. Myth 1, it is just a smarter chatbot. No. The news is proactive autonomy, its own clock and triggers and standing access. Myth 2, it runs on my phone and it is magic that it works when my phone is off. No. It runs on Google's cloud machines, and your device being off is irrelevant because the agent was never on it. Myth 3, it buys things for me automatically. No, the ship default is that it asks first. Delegated spending with limits is the roadmap, not today. Myth 4, it cannot be tricked because Google secured it. No, Prompt injection is demonstrated against Google's own apps and may be fundamentally unsolvable. Myth 5, anyone can use it now. No, it is a US-only, adults-only beta behind a paid tier, and one cleanup because the announcements get blurred. Spark, the agent that acts, is different from a sibling feature that just sends a proactive morning digest, and from the broader app redesign announced at the same event. Same keynote, 3 different things. Only Spark is the autonomous agent. So step back, because Spark is one instance of a pattern, and the pattern is what you keep. Once AI can act unattended, the central question stops being what can it do and becomes what should I let it do without me? That is a question a teacher, a doctor, a shop owner, anyone delegating routine work now faces. And here is the shape of the whole agent era in one observation. Capability is racing ahead. Safety is not keeping pace. What agents can do climbs steeply, while how safely we can hand them standing access stays nearly flat, with prompt injection still unsolved. That widening gap is the open problem of our moment. Notice, too, how this arrived. Google shipped its most autonomous consumer product deliberately small. Beta, paywalled, one country, safety first, asking before it acts. That restraint is itself the message. The technology to let AI run your digital life on its own clock exists now. How fast and how widely we hand it the keys is the choice in front of all of us. So here is the whole thing in one line. We are moving from AI that waits for us to ask to AI that acts on its own clock, and the real question is no longer what it can do, but how much we let it do without us watching.